All right, 18CD to me is what we essentially do at 11 and 12. We pretty much rely on the understanding of stationary points, and a lot of students confuse them with x-intercept, y-intercept, because if you notice, a lot of our calculations, often it equals 0. So null factor law equals 0. That was one of the first things you did in quadratics. Or in year 9, x-intercept, y-intercept, you let x equal to 0, y equal to 0. And then now we're up to derivatives. Again, it's letting equal to 0. So a lot of students have no idea. A lot of students, generally get confused about why it equals to 0. And then it's like, when do you use it? How do you use it? So I'm always going to try to remind you, derivative is to find what again? Every time you do the derivative, you are finding the gradient. You just can't forget that. It's the gradient of a tangent line using 1 point. Okay, only 1 point. That's one of the first things you have to understand, right? Now, our last session, 18A, you learnt tangents and normal. They're saying that when you have a random curve, okay, tangent is you pick a point. Tangent is the straight line that touches that point once. So straight line we know is y equals mx plus c. When you find the derivative, you're only just finding m. That's it. That's the only part that is different to year 9, y equals mx plus c. You're just using derivatives now. So you learned the 7 rules last term to find that. That's all you're doing, just finding m. Then yesterday's lesson, we introduced normal. Normal just means perpendicular line. So you learnt that in year 9 that you can find a perpendicular line. If you know M1, then you can find M2, because that green line there is also another straight line. It's y equals mx plus c. And the relationship between the two is that if M1 times M2 equals -1, they are perpendicular. Okay, so that was 18A. What's nice about 18C and D, why it is the sort of bread and butter of calculus application, is because we are studying what happens at every single point on that curve. What happens to the tangent line? See, right now, if I choose that point, clearly we can see gradient of the tangent line. Even though I don't know what it is, I do know it is positive. I don't know the value, but I know it's a positive gradient. I can say that at this random point, if I picked this point, for example, if I picked this point and asked you to draw a tangent line, I may not know what the gradient is yet, but I do know one thing is the sign of that gradient must be what? It must be negative, right? So we can tell a couple of things just looking at the curves. We know that gradients have 4 types: positive, negative, 0, and undefined. One of the special things is that in every curve that you draw, when you get to a maximum and a minimum, you can actually predict what the tangent or the sign of the tangent should be. So looking at this curve here, let's have a look. We can already see if I picked any points here and I drew a tangent line to each of those points, what sign is the gradient at the moment? What sign? Positive. So we say positive, positive, positive. But we can see that, yes, that's steep. It's a steep gradient, but as you go closer and closer to point A, what have you noticed about the gradient? It's getting flatter. But if the gradient of the tangent line is getting flatter, even though it's still positive, the result is by the time you get to the very maximum point, what gradient is this now? 0. This gradient at the very top, if I asked you, what is the gradient of a tangent line to skim the very top? It has to be a nice gradient of 0. So we had positive, 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 0. But as soon as you pass A, if I picked another point now, I picked over here. All these points here, even though I don't know what the gradient is, I can tell that each tangent line has a gradient sign of what sign? What signs all these gradients here? negative. And then back to B again, you notice that right at this point here, which is an inflection point, which you learned back in cubics, inflection points get flat right at that particular point. So again, it's 0, and then as you can see, as I keep going, it is continuing to be negative, 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 but only at this particular point, gradient 0. So if you have a look at the pattern, you start to see that every time you get to the very bottom, so minimum, or you have an inflection point, which is a cubic, that inflection point thing that you've remembered, and this is a maximum. These 3 sections, it's special because the gradient is 0. And they gave it a special name. That's all it was. The study of calculus is literally doing what we just did here, is that you don't need to yet know what the value of the gradient is at each point, but you can already tell just by looking at the pattern of the gradients. Gradients here are all positive. By the time it reaches maximum, it's 0. As soon as you pass the maximum, it starts to go to the negative region. So tangent's all negative from here, 0 there, negative, 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 0. And then as you turn, the gradient at each point is positive. So what we're studying here is that we know, well, actually every maximum or minimum has a derivative of 0. And so that's special because that means you can have really large curves, or at the start of the year when you learn cubics and you said, how do we find the turning points? Well, this is one of the techniques. We know that cubics, they have 2 turning points, a maximum and a minimum. You can work that out by finding the derivative of a cubic function. Then let it equal to 0, because if the derivative equals 0, it means the gradient is 0. Then you know it's either a maximum or a minimum. Okay, you just don't know which one yet. Does that make sense? So in a nutshell, what you're learning from C and D is that we are understanding that when the derivative delta y delta x equals 0, which means, just write in your notes here, right, so to remind yourself, when gradient equals 0, so when gradient equals 0, you have either a max, minimum, or an inflection point. That's pretty much the takeaway point. That's the takeaway. The takeaway in today's lesson is to understand that if we're just studying the gradients of each tangent line, the pattern is that delta y delta x, which is the derivative, if the derivative equals 0, the gradient equals 0. And then when the gradient equals 0, we can see the pattern is either it's going to be a maximum point, minimum point, or an inflection point. That's all it is. And so you can derive the curve. You are able to find the maximum or minimum or inflection points. Okay, that's why it was important that you had to learn the 7 rules that no matter which function I give you, you can derive it. Okay? All right, so what's the special name for it? It's called, the name for those specific points when the derivative equals 0 is called stationary points. Okay, so stationary point can be a stationary point of maximum. It could be a stationary point of minimum. So minimum stationary point, maximum stationary point, or an inflection point. Okay? So today's practice is for you to find maximum and minimums of curves that you didn't or couldn't do at the start of the year. Here's an example. Let's do an example so we can tie it all together, okay? So you have maximum point, inflection point, and the last one was minimum. That was cool. So just filling that in. Minimum point. And this one is called a gradient table. Later on, you'll use it to justify if you know it's a maximum, minimum, or inflection point. But the idea is, wherever the point is, so at point A, we can see that point A. Let's say I said that was at -1. Then that means if I chose a number smaller than -1, for example, -2, then I expect the gradient to be positive. So they're just saying, if I picked -2, the gradient should be positive. And if it's positive, it looks like this. 0 has this. And then if I picked a number up greater than -1, so say 0, then I know the gradient should be negative, and it looks like this. And you can see that gradient then gives you this maximum look. Okay, so this is called a gradient table so that you can prove where it's a maximum point or minimum point. So what I'm trying to explain here is this idea. So I'm going to say it again, just so it makes sense to you. So I'm saying at point A, see here's point A. Point A is at, and I said -1. If you picked a number smaller than -1, so -2, then at this point, gradient is positive. If you picked a point after -1, so say, I don't know, -0.5, this point here, it's minus. So if we follow that, well, the trend is at -2, you get a positive gradient. At -1, you get a 0 gradient. And at -0.5, you get a negative gradient. This is a proof to imply that at point A, the stationary point has to be a maximum. Because you've got 3 types. You've got maximum, inflection, or minimum. If you don't have a graph, how do you know if it's a maximum, minimum, or inflection point? Gradient table is how you show it. Okay, we'll do that later. That's more of a justifying question, and you'll get to practice that in the questions. But let's start off. Let's do a question where you derive, find the stationary point, and then we're going to determine, is it a maximum, minimum, or inflection point? Okay, so let's flip over. Let's flip over the page. Let's have a look at this. Back all the way to quadratics in term 1. So in term 1, there was a formula I gave to you guys to find the turning point. There was a couple of skills you had to do. You either complete the square, read the turning point, or you used, anyone remember, what was the rule that I gave to you to find the x coordinate of the turning point again? Anyone remember? What was the rule? Beautiful. X equals minus b over 2a. I'm going to show you shortly where that formula comes from. And that comes from derivatives, and it comes from this particular exercise. So you had to know this exercise in order to understand where the proof came from. But let's start off. I want to find the turning point. Instead of completing the square to find out where that minimum point is, I can already see if I drew a tangent line right at that point, gradient has to be 0. Yeah, so gradient of the tangent line at that particular point has to be 0. So I'm going to draw that line again just to help you understand. So here's the tangent line. The only way to draw a tangent line that touches that particular point is the gradient of this y equals mx plus c has to be 0. So to find the gradient, year 11 calculus is the only thing you're learning at this point. So to find the gradient, find the derivative. Let's go. What is the derivative of x squared minus 6x plus 5? Let's go with Adi. 2x minus 6. Beautiful. So we are now able to use power rule. Find the derivative. Great. The derivative of x squared minus 6x plus 5. So I'm just going to write here power rule for those who weren't sure of how to do that. Power rule. We've got 2x minus 6. But what do I want? I want to find the derivative at which point now? So this is the gradient formula, but I don't want any random gradient. I want to know when the gradient is 0, because when it's 0, I should have a max, min, or an inflection point. Now what's nice about this is I gave you a graph, but if I didn't give you a graph, you wouldn't have known, is it a maximum or a minimum? And so how do you find out? You just know, let's find a stationary point. So here we say, stationary point occurs when delta y delta x equals 0. So we know that a maximum, minimum, or an inflection point will occur when the derivative equals 0. So we say, okay, here we go. Let's solve for it. That means 2x minus 6, which is your derivative, dy dx, if it equals 0, meaning if the gradient equals 0, you're now solving for x. And what that x tells you is where should the gradient equal to 0? Where will it equal to 0? That's what you're solving for. So here we go. Add 6 on both sides. Divide both sides by 2. X equals 3. What does that mean? This means that we now know when the x coordinate is 3, which we don't know what the y coordinate is yet. We just know when x is 3, the gradient will be 0. Okay? Now, how do you find the y coordinate again? What do? In this step here, a lot of students mess up. I see it all the time. It's because they're not thinking about what the mathematics is doing. What do we do from here?
Oh, you have to sort it back to the original.
Okay, now which one's the original?
The x squared minus 6.
Beautiful. Most common mistake is students take this 3 and they sub it back in here. What do you expect to get if they sub in 3 into delta y delta x? What should you get? 0. Which is it's like a circular argument. You say, when will the gradient be 0? So you worked out when it will be 0. You say x equals 3. And then I see a lot of students just sub it back in and then write 0. I'm like, yes, you already knew that. You said, I want 0. What should x be? You figured out x was 3. But that doesn't tell you y. If you want y, that's the equation for y. That's the relationship between x and y. So the one that you sub back in is into the original to find y. This one's to find gradient. They're two different things. Yeah? So don't just do things because it's a method, but think about what you're actually doing here. So we're going to sub it back in. We're going to say sub it back into this one to find the y coordinate. So y should equal to 3 squared minus 6 times 3 plus 5. 9 minus 18 plus 5. That's negative 9 plus 5 is negative 4. So what that tells me now is I've just worked out that the stationary point, which again, I don't know if it's a maximum, minimum, or an inflection point. I know from looking at the graph, but had I not given you the graph, the coordinates 3, negative 4 doesn't really tell you anything. You don't know if it's a maximum, minimum, or an inflection point. Okay, so clearly in this graph, we know that this is clearly a minimum. But how do you prove it? So that's what the previous page was when I was saying, well, just because you've got a stationary point, how do you know if it's a maximum or a minimum or an inflection point? So what we do is we then use a gradient table. So here's a gradient table. I'm going to do it in a different color. Gradient table. Here we go. Let's check if it's a minimum or not. How do you do it? Select the x coordinate. So you know at 3, when x equals 3, is here, when x equals 3, the derivative, so delta y delta x, was equal to 0. If you want to prove that this is going to be a minimum, in order for it to be a minimum, that means on the left of 3, so if you go smaller than 3, the gradient should be negative. And then if you go right from 3, so a number that's bigger than 3, the gradient should be positive. That's the only way for you to get negative, 0, positive types of gradients for it to start looking like a minimum point. Okay, so this is how you prove it. So here we choose any number less than 3 to be the left value. And you can choose whatever number. It could have been 1, could have been 2. I would choose 0, just because 0 is easier. Now if I choose 0, how do you show that the gradient is going to be negative? Where do you sub it in? So I'm saying when x equals 0, right over here, if x equals to 0, and I want to know that the gradient is definitely going to be negative to be able to prove that the left of 3, so at 3, 0, I want to show it's going to be a negative on the left of 3. Where do I sub 0 in? Where do you sub 0 in to show that the gradient is going to be negative? Think about the language I'm saying. I want the gradient. Which one's my gradient equation? 2x minus 6, not this one. So this one tells you the x and y coordinates. This one tells me whatever I sub in for x. So if I sub x, I should get derivative. Derivative is the gradient. Yeah, so here, if I sub 0 into this equation, this now becomes 2 times 0, was it minus 6 or plus 6? Minus 6. This gives me negative 6. So in terms of the shape, the tangent line should be a negative shape. 0 should look like this. And now you just got to pick another number bigger than 3. I'll probably just pick 4. Find the gradient, same thing again. 2 times 4 minus 6. 2 times 4 is 8. 8 minus 6 is positive 2. Positive gradient. At year 12, if they asked you to justify, this is what you must do. You actually have to do the calculations to show that you know it's a minimum. Because clearly, negative gradient, 0 gradient, and positive gradient only implies this stationary point has to be a minimum. Can't be anything else. Yeah? So that's the point of the gradient table. So you got 3 scenarios there. You either have 0 gradient here, positive when you go to the left, negative when you go to the right. This is called a maximum. If you had a 0 gradient, but on the left it was negative, and then on the right it's positive, this is called a minimum. And if you had 0 gradient, but then on the left it's negative, and then on the right it's negative, that's called an inflection point. But you can also have an inflection point the other way. You could have had positive, 0, positive. This is called a gradient table. You've got 3 scenarios to prove whether it's an inflection point, minimum point, or a maximum point. Okay? I'm going to zoom out just so you can see again. What's the goal today? The goal is studying gradients of tangent lines. Specifically, when the gradient of a tangent line is 0. That's called a stationary point. Stationary points have 3 types. You either have max, min, or inflection. You just got to prove it. Okay? Let's try this one. So this time, I'm going to give you an example 2, but it doesn't have a graph. So the first one had a graph. It was easy to picture, and you were able to tell there was a minimum. But what about this equation? I want you to have a go with this. I'm going to pause the video. You've got this cubic. Most of you probably can't yet visualize what this cubic looks like. You've got y equals x cubed minus 4x squared minus 3x plus 18. So you haven't got a visual idea of what this looks like yet. But I want you to tell me where are the maximums and minimum points. Because in a cubic, usually you can get maximum, minimums, or an inflection point. Have a go with this one. I'm going to pause the video. See if you can put it all together now. So let's try this example. I'm going to pause the video. So let's see what you did. Hopefully you found the derivative. Hands up if you got derivative 3x squared minus 8x minus 3. Good, that's the first step. Usually the first mark to this kind of problem as well. So in year 12, that usually is the first mark or first step. Sometimes the examiners may not give you that mark until you do this next step. So sometimes examiners may put the marking scheme right here to say that, well, just because they can find the derivative doesn't mean that they know what to do next. The point is you're trying to find a maximum or minimum. So you've got to say something like stationary points occur or maximum occurs when derivative equals 0. And that line there, so derivative equals to 0. So 3x squared minus 8x minus 3 equals 0. That could be the first mark in your calculation. So now that I've got this equation, if I can solve for x, that will tell me where I will have a gradient of 0. Okay, this represents gradient. Okay, not y-coordinate, this represents gradient. So where do I have gradient of 0? Just solve for that one. That's a quadratic. Factorize it. So here we go. We factorize the equation. We factorize the equation. And I got 3x plus 1, x minus 3, all the way back to term 1 stuff. Solve for x using null factor law, and I get x equals negative 1/3 and 3. Sometimes this is a second mark, sometimes it's not. Hands up if you got x equals negative 1/3 and 3. Okay, good. For those who tried, yes. So we got x equals negative 1/3 and 3. What this means is the 2 coordinates, possible coordinates anyway, are this. This is what we figured out. We have either inflection point max min, inflection point max min. We don't know yet. We just know these 2 points. We'll have a gradient of 0. X equals negative 1/3 and x equals 3. What I don't know is what the y coordinates are. So what do? You sub in the x coordinate back to the original equation, not this one. This one's a gradient equation. So you sub it back into the cubic to find y. Okay, so I did it on a CAS calculator. I just, whoops, that one, this one. I just defined the function and I subbed in, oh, that's wrong actually, my bad. That should have been negative a third. And 500 on 27, so it should have been 500 on 27. My bad, 527. And let me just fix that one. 500 on 27. So now we've got the coordinates for one, and the other one should have been f of 3, which gives you 0. So that means the two coordinates that you end up with are these 2 points. Negative a third, 527. That's a point. And the other point is at 3, 0. What we don't know is this point a maximum or a minimum? Is this point a maximum or minimum? Obviously, if we sketched it on a CAS, we'd be able to see which one should be a max min. Or if you use a bit of logic, because it's a cubic graph, and you've got two stationary points, it's very likely it could either look like this, or it could look like this. So since that's negative 1/3, which is to the left, it could either be a maximum or it could be a minimum. But based on the equation of the graph, was it a positive cubic or was it a negative cubic graph? The equation I gave you. Is it a positive cubic or a negative cubic? Positive. So likely, I can already say this is going to be a maximum, logically, and this one has to be a minimum, right? But you've got to prove it. You can't just say, logically, I know the answer is this. Okay? You have to then prove it. So here we're going to actually prove it. Let's see if it's actually a maximum as we predict. So to know if it's a maximum or not, we expect to be a positive gradient here and then a negative gradient on this side. So you're just going to pick two numbers. One number that's smaller than negative a third and one number that's greater than a third. Numbers I would pick, I pick 0. 0 is greater than negative a third and maybe negative 1. Just pick easy numbers so you can sub in. Now where do you sub this one in? Not back into the original equation because that's x and y. You're trying to find gradient. Sub back into the gradient formula. So what I did, here we go. I defined the derivative as d of x. Okay, so I said d of x equals to this. That's my derivative equation. Let's find out now. D of negative 1, I get 8. So this gives me 8 as my gradient, which is positive, which makes sense. That's true. We already know when x equals negative a third, the gradient is 0, so you don't have to test that because we already did it over here. And then over here, we just need to know what's the gradient when x is 0. So here we go. D of 0, it's negative 3. And I've proven that yes, you pick a number that's greater than x equals negative a third, I should have a negative gradient, and I do. So positive gradient 0, then negative implies this must be a maximum. Okay, so it should be a maximum stationary point. And then similarly, if you did the same one for 3, 0, we expect it to be a minimum. For it to be a minimum, this should be negative and this one should be positive. How do you test it? Pick a number smaller than 3 and then bigger than 3. So you can do 1 and you can do 4. And you actually have to write in the numbers and calculate them. So d of 1, d of 4, and you can see negative 8, 13 proves my point. So this must be a minimum. So even though we can't see the graph, listening, even though we can't see what the graph looks like, I can already predict what each of these points are. So if you now go back to your cubic knowledge from term 2, you are now able to find x-intercepts, y-intercepts, and you can just find turning points because I already found them. That's my maximum, that's my minimum. I can do all that by hand. So sometimes at a year 12 level, sometimes in the exams, they get you to do the whole shebang. So they get you to sketch this graph, label the endpoints, label the axis-intercepts, and label the turning points. Okay, so it's a huge calculation set, but you can do it all by hand and work out key features of a cubic graph. Okay? That's it for today. That's pretty much what I wanted to show you. So understanding what the derivative actually means, it's to find the gradient of a tangent line with one point. Okay, and you need to know the 7 rules to apply this. So chapter 18, your SAT is likely to be like this. This is what you're dealing with. You're going to deal with a problem, a curve, and you're going to find maximum, minimums, endpoints, axis-intercepts, everything that you've learned throughout the year applies here. That's why calculus is 3/4 of your course. Okay? All right, I'm going to stop the video there.